Find the intercepts and asymptotes, then sketch a graph of the rational function and state the domain and range. Okay, in order to graph a rational function, there are a couple things you need to remember before you can graph it. First one is going to be your zeros, or your intercepts, because we can find the y-intercept pretty easily. 2 is going to be your end behavior. Three, we're going to have to find my asymptotes. And then 4, I need a sign chart. Okay, so I'm going to do these 4 things. So let's do the first one first. So find the zeros. The zeros are going to be pretty much wherever the top is 0. So if I factor the top, it's going to be x minus 1 and x minus 1. So my zeros are going to end up hitting, so my zeros are going to be at x equals 1. But that's actually going to happen twice. So it's going to be x equals 1 with a multiplicity of 2. And that's the x-intercepts. Y-intercept is if I set everything equal to 0. Set this equal to 0 and this equal to 0. You end up getting 1 over 1. So my y-intercept is actually going to be y equals 1. But I'm not going to worry about that too much. End behavior. End behavior pretty much comes from this piece right here. If you remember, it's just the leading term divided by the leading term. So then it's going to be x squared divided by x squared. So that equals 1. So in other words, the limit as x goes to infinity and the limit as x goes to negative infinity of r of x is going to be 1. Of r of x is going to be 1. So that's my end behavior. And then I'm going to do my asymptotes. Asymptotes are where the bottom is 0. So if I factor the bottom, it's going to be x plus 1 and x plus 1. So my asymptotes are going to be at x equals negative 1, and that's going to happen twice as well. And then I need to do a sign chart. So sign chart. So what I'm going to do is I'm going to take my zeros, plot them on my sign chart, my asymptotes, and plot it on my sign chart. And then we're going to check different places. So if I check 0, so I'm going to check 0 here. 0 minus 0 plus 1, 0, we already knew that was 1, so that's positive. So it's going to be positive right here. And then I'm going to check something past 1, so let's check 2. So I end up getting, let me get rid of this really quick. So I'm going to plug in a 2. 2 squared is 4. Minus 2 times, negative, minus 2 times 2, which is 4, plus 1. So you end up getting 4 minus 4 plus 1, which is 1 on top. And then if I plug in a 2 on the bottom, I end up getting 4 plus 1, which is going to be 9. So that's going to be positive on the bottom. So positive divided by positive is positive. So that's going to be positive. Now if I plug in a negative 2, so in other words, I plug something in over here, negative 2 is going to be 4, negative 2 minus 2, which is going to be plus 4, plus 1 is going to be on top, and then down here it's going to be 4, negative 2 times 2, which is minus 4, plus 1. It's going to be positive and positive again, so it's going to be positive everywhere on the graph. So the sign chart tells me a lot. Now that I have all this information, I'm going to plot my zeros. So my 0 is going to be at 1. So there's going to be 0 right there. And then I'm going to have my asymptote, which is going to be negative 1. And then I have a horizontal asymptote at 1. So we're going to start off our graph coming from 1. And then when we get to this point, I need to go up because my graph always needs to be positive. So this goes up. And then it comes back down from here because my graph still needs to be positive. Then I know my y-intercept is going to be 1, so it's got to go through this point right here. Now, remember, a horizontal asymptote, you can actually cross through in the middle of the graph. That just shows us the end behavior, not an actual asymptote. So then it's going to come down here, and since it always needs to be positive, it's going to actually bounce off this point and then go back to my asymptote. So my graph looks like this. So my domain is going to be everywhere except for my asymptote, which is going to be at -1. So my domain is going to be negative infinity to -1 with the union of -1 to infinity. And then my range looks like it's going to be from here on, and it does include this point. So I'm going to say from 0 up. So it's going to be from 0 to infinity.